Here are 10 bird facts you can listen to in English. Now, let's get started.
Bird stabilizer. Have you ever wondered how a chicken can keep its head perfectly still even when its body is moved around? This remarkable ability, sometimes called the bird stabilizer, is thanks to an extremely sophisticated biological system. It's an advanced form of the vestibulo-ocular reflex. This reflex, which is present in most vertebrates, including humans, stabilizes vision during movement. In birds, however, it is exceptionally powerful. When a bird's body moves, its inner ear instantly detects the motion and sends signals to the neck muscles. These muscles then make precise, rapid adjustments to keep the head locked in place, ensuring their visual field remains stable. This is crucial for spotting predators or prey while in motion. This natural stabilization system is far more complex than it might appear. While it provides incredible stability for rotational and translational movements, its effectiveness is optimized for specific frequencies of motion that birds typically encounter during flight or walking. Interestingly, this biological marvel has inspired engineers. The principles of the vestibulo-ocular reflex have been studied to develop better image stabilization technology for cameras and drones. However, even the most advanced artificial systems struggle to replicate the efficiency and seamless integration of sensory input and motor output that birds achieve naturally.
Submarine penguin. How can a bird survive diving to depths that would crush most other animals? The emperor penguin is a master of the deep, holding the record for the deepest and longest dives of any bird. Official records show they can plunge to a staggering depth of 565 meters and hold their breath for up to 22 minutes. To withstand the immense pressure, which can be over 50 times that of the surface, emperor penguins have solid, heavy bones, unlike the hollow bones of flying birds. This reduces buoyancy and helps them descend more easily. The penguin's ability to stay underwater for so long is due to a suite of remarkable physiological adaptations. Upon diving, they activate a dive reflex, dramatically reducing their heart rate from a resting rate of about 70 beats per minute down to as low as 15 beats per minute. This process, known as bradycardia, significantly conserves oxygen. Furthermore, they can redirect blood flow away from non-essential organs and muscles, ensuring that the brain and heart receive a constant oxygen supply. This incredible oxygen management is the primary reason they can spend such extended periods hunting for fish and krill in the deep Antarctic waters. Hectic hummingbird. Have you ever wondered how hummingbirds sustain their incredibly fast wing beats? These tiny birds, the smallest in the world, are masters of hovering flight, a feat they achieve by flapping their wings up to 80 times per second. This intense activity requires a heart that can beat over 1,200 times per minute. To power this extreme metabolism, a hummingbird must consume a massive amount of high-energy food. In fact, on a typical day, it will consume more than its own body weight in nectar, visiting hundreds of flowers to get enough fuel. To survive the night or periods when food is scarce, hummingbirds have a remarkable energy-saving adaptation. They can enter a state of inactivity called torpor, which is similar to a short-term hibernation. During torpor, their metabolic rate can drop to 1/15 of its normal rate. Their body temperature, which is typically around 40 degrees Celsius, plummets significantly, and their heart rate slows to fewer than 50 beats per minute. This allows them to conserve the precious energy they've gathered during the day. Ostrich's brain. Is it true that the ostrich, the world's largest bird, has a brain smaller than its eye? The answer is yes. An ostrich's eyeball can be up to 5 centimeters in diameter, making it the largest of any land animal. In contrast, its brain weighs only about 40 grams, which is indeed smaller than one of its eyeballs. For many years, this simple anatomical fact has led to a common perception that ostriches are unintelligent birds, often used as a symbol of foolishness for supposedly hiding their heads in the sand. However, this view of the ostrich's intelligence is now considered an oversimplification. Modern biologists argue that brain size alone is not a reliable measure of intelligence. The ostrich's brain, while small, is highly optimized for its survival strategy. A large portion of the brain is dedicated to processing information from its excellent eyesight, allowing it to spot predators from as far as 3.5 kilometers away. Therefore, their brain isn't necessarily lacking. Rather, it is extremely efficient and specialized for the specific needs of a creature that must constantly watch for danger. Sky sleeping bird. Have you ever wondered if birds can sleep while flying? For the great frigate bird, a seabird with a wingspan of over 2.3 meters, it's not just possible, it's a necessity. These birds can stay aloft for weeks, covering thousands of kilometers without landing. To achieve this, they've developed an extraordinary sleep mechanism. On average, a frigate bird sleeps for only about 42 minutes a day while in flight, a tiny fraction of the 12 hours they sleep on land. This in-flight sleep is taken in extremely short bursts, averaging just 10 to 12 seconds at a time. This is accomplished through unihemispheric sleep, where one half of the brain sleeps while the other half remains awake and alert, allowing the bird to navigate and avoid collisions. This unique adaptation is crucial for their survival strategy of long-distance foraging over the ocean. Surprisingly, researchers also discovered that frigate birds can engage in bihemispheric sleep, where both halves of the brain are asleep, for brief moments. This typically occurs when the bird is ascending on rising air currents, a time when the risk of collision is lower and aerodynamic control is less demanding. This ability to snatch seconds of sleep in two different ways allows the frigate bird to overcome the physical limitations faced by most animals, enabling its marathon flights.
Billions to none. Could the most numerous bird on Earth vanish in just a few decades? This is the tragic story of the passenger pigeon. In the early 19th century, North America was home to an estimated 3 to 5 billion of these birds. Their flocks were so immense, they would darken the sky for hours, sometimes even days, as they passed overhead. Witnesses described flocks that were more than a mile wide and took 14 hours to pass, a spectacle of nature unlike any other. However, this abundance was also its downfall. The primary cause of the passenger pigeon's extinction was commercial hunting on an industrial scale, which began in the mid-1800s. The expansion of the railway network allowed professional hunters to follow the massive nesting colonies, killing millions of birds. The pigeons were packed into barrels and shipped to feed the growing populations in eastern cities as a cheap source of meat. This relentless pressure, combined with their communal breeding habits, meant the population could not recover. By 1900, the bird was almost entirely gone from the wild. The last known passenger pigeon, named Martha, died in the Cincinnati Zoo on September 1, 1914, marking the complete extinction of the species.
Toucan's beak. Have you ever wondered how a toucan stays cool in the hot tropics? The answer lies in its enormous 20-centimeter-long beak. This beak, which can be a third of the bird's body length and 40% of its total surface area, functions as a highly effective radiator. It is filled with a dense network of blood vessels, and by controlling the blood flow to this large, uninsulated surface, the toucan can precisely manage its body temperature, radiating away up to 4 times its resting heat production. This adaptation is vital as birds are unable to sweat. for a long time, the beak's primary purpose was a mystery. Early naturalists, including Charles Darwin, proposed various theories. Darwin suggested it was for attracting mates through sexual selection. Other common ideas were that it served as a weapon against rivals or a specialized tool for peeling and reaching fruit. While the beak does assist in feeding, modern thermal imaging has shown that its most critical function is, in fact, thermoregulation, updating our understanding of this iconic feature. Giant baby. Did you know there are chicks that can look larger than their parents? King penguin chicks are unbelievably huge. This massive size is the key to an astonishing survival strategy, enduring a fast for up to 5 months during the harsh and Arctic winter. To achieve this size, their parents feed them huge amounts of food, helping them build fat reserves and reach a weight of around 12 kilograms. It's this stored energy that allows them to survive temperatures as low as -30 degrees Celsius. By the time spring arrives, they will have lost nearly half of this initial weight. The reason for this extreme fasting is tied to the king penguin's unusually long breeding cycle, which lasts over a year. This extended timeline means that the parents have no choice but to leave their large, brown-feathered chicks on the shore and return to the distant sea to forage for food during the winter months. The chick's ability to fast is therefore a direct evolutionary response to this prolonged period of parental absence, ensuring the continuation of the species in a challenging environment. Dangerous bird. Have you ever heard of a bird so dangerous it's been compared to a dinosaur? The cassowary, native to the rainforests of New Guinea and Australia, holds the Guinness World Record for being the world's most dangerous bird. This flightless giant has a formidable weapon, a 12-centimeter-long, dagger-like claw on its inner toe. With its powerful legs, a cassowary can deliver a kick strong enough to break human bones and cause fatal injuries. It can run at speeds up to 50 kilometers per hour through dense forest and jump nearly 2 meters into the air, making it an animal to be treated with extreme caution. However, the reputation of the cassowary as an aggressive killer is somewhat misleading. While undeniably dangerous, these birds are naturally shy and wary of humans. A comprehensive study of 221 recorded attacks found that a significant majority, about 75%, occurred because humans were attempting to feed them, causing the birds to lose their natural fear. Most other incidents involved the birds acting in self-defense, either for themselves or to protect their eggs or chicks. Fatal attacks are exceptionally rare, with only 2 reliably documented cases involving humans, and both were a result of the bird being directly provoked or cornered. Talkers and squawkers. Why can some birds, like parrots, imitate human speech with incredible accuracy while others cannot? The answer lies not just in their vocal cords, but deep within their brains. Parrots, along with other vocal learners like songbirds, possess a highly complex syrinx, the avian vocal organ. This organ has intricate muscle structures that allow for precise control over a wide range of sounds. More importantly, their brains contain specialized neural circuits dedicated to learning and reproducing sounds. These pathways connect the forebrain to the syrinx, enabling them to memorize, process, and replicate complex sounds, including human words. In contrast, birds like chickens and pigeons lack this sophisticated neural architecture for vocal learning. Their syrinx has a much simpler muscular structure, limiting the variety of sounds they can produce. Critically, their brains do not have the specific song-learning circuits found in parrots. As a result, their vocalizations are almost entirely innate, meaning they are genetically programmed and not learned through imitation. This fundamental difference in brain structure is the primary reason why a chicken can't be taught to say hello, no matter how much you try.